Welcome to AminAcademy.com. In Fourier transform, let us do some introduction. The Fourier series expresses any periodic function into a sum of sinusoids. The Fourier transform is the extension of this idea of to non-periodic functions by taking the limit form of Fourier series when the fundamental period is made very large, that is infinite. Fourier transform finds its application in astronomy, signal processing, linear time invariant, some systems, etc. In physical and mathematics, Fourier transform, that is FT, is a transform that converts a function into a form that describes the frequencies present in the original function. The output of the transform is a complex valued function of frequency. Fourier transform is an important image processing tool which is used to decompose an image into its sine and cosine components. The output of the transformation represents the image in the Fourier or frequency domain, while the input image is the spatial domain equivalent. Here, some useful result in Fourier transform in tabular form. The function integral 0 to infinity e power minus ax sine lambda x dx is equivalent to transform of lambda over a square plus lambda square. The second one, integral 0 to infinity e power minus ax cos lambda x dx equal to a over a square plus lambda square. Third one, integral 0 to infinity sine lambda x over x dx equal pi by 2 when lambda equal to greater than 0. When lambda equal to 1, substitute lambda equal to 1, we have this function becomes integral 0 to infinity sine x by x dx equal to pi by 2. Here, fourth one, sine ax equal transform of sine ax equal Fourier transform e power iax minus e power minus iax over 2i. Transform of Fourier transform of cos ax equal e power iax plus e power minus iax over 2. Sixth one, integral 0 to infinity e power minus a square x square dx when a equal to 1, a power x, integral 0 to infinity e power minus a square x square equal to 0 root of pi over 2a. When a equal to 1, you substitute a equal to 1 here, that is integral 0 to infinity e power minus x square dx equal to root of pi by 2. Heaviside step function or unit step function h of t or u of t when 0 equals 0, when t equals lesser than 0, when u of t equal to 1, when t is greater or equal to 0. At t equals 0, h of t is sometimes taken as 0.5 or it may not have any specific value. Shifting t equal to a, h of t minus a, before h of t is there, here h of t minus a because of shifting t equal to a, or u of t minus a is 0 when t is lesser or equal to a and 1 when t is lesser, greater or equal to a. Eighth one, Dirac delta function or unit impulse function is defined as such that integral 0 to infinity delta of t minus a dt equal to 1 when a is greater or equal to 0. It is 0 anywhere except one point a. The delta function is sometimes thought of having infinite value at t equal is not equal to a, equal to a here, not equal here. At equal to a, the delta function can be viewed as the derivative of the Heaviside step function. Now let us discuss about Dirichlet's conditions for existence of Fourier transform. Fourier series is in general tends to converge slowly. In order for a function f of x to be expanded properly, it must satisfy the following Dirichlet conditions. That is, a piecewise function f of x must be periodic with at most a finite number of discontinuities and or a finite number of minima or maxima within one period. Now, the Fourier transform can be applied to any function f of x if it satisfies the following conditions. That is, f of x is absolutely integrable, that is integral minus infinity to plus infinity of f of x dx is convergent. The second condition, the function f of x has a finite number of maxima and minima. Third condition is f of x has only a finite number of discontinuities in any finite. Now, Fourier transform, here we can discuss further. Fourier transform, inverse Fourier transform, inverse Fourier transform and Fourier integral. And about these things we will discuss. Here, for example, here f of x, that is a function f of x gives Fourier transform, then which gives f dash of lambda. The Fourier transform of f of x, that is Fourier transform of f of x, that is minus infinity to plus infinity, denoted by f dash lambda, where lambda is an element of n, natural number, is given by that is capital F of f of x is identical, that is congruent with f dash of lambda, which is equivalent to 1 by root of 2 pi integral minus infinity to plus infinity e power I lambda x f of x into f of x dx, let it be 1. Also, inverse Fourier transform. inverse Fourier transform of f dash of lambda gives f of x as it given as f of x as that is f of x is the function from the Fourier transform which is gives the inverse Fourier transform is 1 by root of 2 pi integral minus lambda infinity to plus infinity e power minus I lambda x f dash of x that's f plus lambda, not x here, lambda d lambda, let it be 2. Rewriting 1 as f, that is therefore f dash of lambda can be written as 1 by root of 2 pi integral minus infinity to plus infinity e power I lambda t f of t and f of t dt, and using into Fourier integral represent f of x. Therefore, Fourier integral of f of x is given as equal f of x equal 1 by 2 pi minus infinity to plus infinity double integral of minus infinity to plus infinity e power I lambda t minus x f of t and delta lambda. This is a Fourier integral. Inverse Fourier transform is given here. So far we discussed about the introduction of Fourier transform and inverse Fourier transform and Fourier integral and Dirichlet conditions for Fourier transform. Further videos we will discuss about some example problem of Fourier transform. We have done. Please subscribe our YouTube channel.